Welcome to the section 4.4 notes. Go ahead, pause the video and work out this warm-up. Should not take you very long. This is kind of an algebra 1 thing, but we're going to be doing something similar today in the notes. So go ahead, pause the video, work out this equation, and then come on back and see how you did. So I know my b value is positive 2, and I can find my slope. Okay, pick any 2 points. I'm going to pick the x-intercept and the y-intercept respectively. I know that my rise is 2, my run is 4, but I'm going the negative direction, so one of those two has got to be negative. So this would be a slope of negative 1/2. So my line would be y equals negative 1/2 x plus 2. The reason we brought that up is because today we are going to be finding the equation from a graph, but obviously in trig we are now going to be using trig functions for these graphs. So remember that the period for sine and cosine is 2 pi over b, and the phase shift is negative c over b, which is the same for tangent. So your phase shift is always negative c over b, but for tangent the period is different. It is pi over b instead of 2 pi over b. So for each of the following, the graph of a trig function is shown. Write an equation that describes the graph. These things over here are going to be kind of important. That's what you want to find. Before you even worry about figuring out what this thing needs to look like, find these things. So to find your amplitude, you can find the highest point and the lowest point. Okay, if they are the same above and below 0. Sorry, my dog's pawing at a toy over here. I apologize about that. So in this case, it's 3 above 0 and 3 below 0. That means our amplitude is 3. Okay, to find your period, pick a point. Usually one that's going to be an easy place to start is going to be at 0, and figure out how long it's going to take until it repeats itself, which in this case is going to be right there. So that is from 0 to 2 pi, so our period is 2 pi. In this case, there's no phase shift, so I'm going to write none, and there's no vertical shift, so I'm going to write none. Now you've got to identify which trig function it is. And I know that a sine wave starts at 0, goes up, and then down and back up. So this is going to be sine with an amplitude of 3. So I'm going to have 3 sine. And then my period is 2 pi, which is the normal period for sine of x. So I'm just going to have 3 sine x. If you want to start putting x in parentheses, that's going to be a good habit to get into for some of these more complicated ones. But that's my answer for number 1. For number 2, again, start by finding our amplitude. Our highest point is at 2, our lowest point is at 0, which means that our amplitude is not 2. You need to find the middle point of that. So halfway between 0 and 2 is 1, so we go 1 above and 1 below it, so our amplitude is just 1. We need to find our period. So again, we start here, we're going to go until we get to here, and that's where we're going to start repeating. That is a period from 0 to pi would be pi. Our phase shift, we're not going to have a phase shift this time. But our vertical stretch, we went from, or vertical shift, excuse me, normally the cosine graph would go through 0, 1. Now it's going through 0, 2. We went up 1. So I'm going to have y equals, and I kind of already identified that it's going to be a cosine. I have a 1 out front for our amplitude. Our period is 2 pi divided by b, right? So in order for 2 pi over b to equal pi, b has to be 2. So I'm going to have a 2x and then plus 1. This is where the parentheses are important. If you don't put the parentheses, it's unclear if that plus 1 is inside of cosine or after the cosine of 2x. What I didn't do on that first question, which I should be doing on all of them, is when I'm done, plug in some numbers to make sure the equation you came up with is valid. So I'm going to start in by plugging 0. Cosine of 0 is going to be 1 plus 1 gives you 2. If I plug in pi over 2, that becomes cosine of pi, which is negative 1, plus 1 is 0. Okay, plug in those values. If I plug in pi over 4, that becomes cosine of pi over 2, which is 0, plus 1 is 1. So this value, or this equation works for the values that we are given. For number 3, this one is clearly not going to be sine or cosine because we've got these asymptotes. Okay, my vertical stretch, this one's harder to see, but if you look carefully, you can kind of see that at like these negative pi over 2 and positive pi over 2 values we're getting 1 and -1, so it doesn't look like there's a vertical stretch at all. So I'm going to put none, which is the same thing as if you put a equals 1. Okay, my period goes from negative pi to positive pi, so it's a period of 2 pi. All right. Now my phase shift, in this case, is going to be none. And my vertical shift, you can't really have much of a vertical shift. So we're gonna have none in this case as well. So I know that tangent normally goes up from left to right. Now it's going down from left to right, so I'm gonna have a negative a value. Okay, and then in order for my period, which is pi over b for tangent, in order for that to equal 2 pi, b has to equal 1/2. Okay, you can solve that just like you would for any other variable. So I got b equals 1/2, so I have tangent of 1/2 x. You could put x over 2, that's the exact same thing. No phase shift, no vertical shift. This is my equation for number 3. Again, plug some values in. So if I plug in any of these negative pi, positive pi, 3 pi, those values I should get asymptotes. I should get undefined answers. So that means, because we have sine over cosine, right? So if I plug in pi, that's negative tangent of pi over 2. Okay, that'd be sine of pi over 2, which is 1 over 0. So those ones will work exactly how they're supposed to, meaning I get an undefined answer. If I plug in 0, tangent of 0 is 0 over 1, which I got. Same thing if I plug in 2 pi, that gives me tangent of pi, which is going to be 0 over -1, so I've got those. The negative part comes in when I pick these pi over 2 values. So if I pick pi over 2, that gives me tangent of pi over 4. Tangent of pi over 4 is 1, but now I have the negative in front. That drops me down to the negative. If I had done tangent of negative pi over 2, or pi over 2 times 1/2, there'd be tangent of negative pi over 4. Tangent of negative pi over 4 is going to be -1. -1 times -1 gives me a +1. So I get that pattern going down from left to right. For number 4, again, we want to find our amplitude first. So our highest value is at 0. Our lowest is at -4. If we find halfway in the middle there, it would be -2. So our amplitude in this case is also going to be 2. Okay, that's the distance from that middle point. You don't have to draw a dotted line. I like to. Up and down be 2. Our period is something that, that's unfortunate. Our period is something that you can find before or after the phase shift, depending on what you kind of want to do in that situation. Let's see how far off this thing went. Not entirely sure what happened to my one note there. All right, here we go. Now we're back at it. So you can go from here to here. Okay, I kind of colored over all these things, but you can see that we're going up by the same values, right? So this is all going up by pi over 4s. So from negative pi over 4 to 7 pi over 4 is a period of 2 pi. Okay, our phase shift, okay, we moved to the left. Okay, if we move to the left, that means we had a positive pi over 4. All right, so your C value is going to be a little bit different than your phase shift. So our phase shift should be negative pi over 4. I misspoke there for a second. Our vertical shift is going to be a little bit easier to see. That's going to be a -2. Now I'm going to come back to this phase shift because what I put here, sometimes it's easy to put the wrong sign, so I like to double check when I go back and plug my values in. So y is going to equal, in this case, I'm going to use a cosine curve. I picked cosine because I went from the top to the top. I think that's the easiest one to see. So my amplitude is 2, so I have 2 times cosine of, now I made my parentheses a little bit bigger since I have a phase shift. So my phase shift, remember we have to figure out our b value, which if our period is 2 pi, then we have a b value of 1. And then our c value, remember it's a cosine bx minus c plus d. So if it's minus c, and I had a phase shift of negative pi over 4, okay, minus negative pi over 4 gives me plus pi over 4. and then the vertical shift of -2. Now this is definitely one where I need to plug numbers in to check, because I have a little bit of everything going on. So I'm going to start by plugging in some of the nicer values where I know it's supposed to be 0. So if I plug in -pi/4, -pi/4 plus pi/4 is 0. So I have cosine of 0, which is 1, times 2 is 2, -2 is 0. Perfect. Okay, same thing if I plugged in 7pi/4, that'd be cosine of 8pi/4, which is cosine of 2 pi, which is 1 times 2 is 2, -2 is 0. If I plug in 3pi/4, that gives me cosine of pi, which is -1, times 2 is -2, -2 is -4. So those values are good to go. Pi/4 and 5pi/4 are the next ones that I'm going to check. So if I plug in pi/4, it gives me cosine of 2pi/4, or cosine of pi/2, which is 0, times 2 is still 0, -2 is -2. Same thing if I plug in that 5pi/4. So this is my correct answer, making sure that you get these signs the correct way. One's going to be positive, one's going to be negative because of this piece right there. And then number 5, I think this is the hardest one out of all of the ones in the notes today. So the highest value is 5, lowest is -1. So to figure out where we are in the middle there, okay, I would subtract 5 minus -1 is going to be 6. Divide that thing by 2, gives me an amplitude of 3. Okay, you can figure out that that's where that middle would be, going through 2. So my period, you can go through a few different ways of checking it out. I'm going to go from there to there, which is 6. We don't have a pi, which is the first time we haven't had pi, so this is going to be something that looks a little bit different than we're used to. Our phase shift, there's none in this case. Okay, our cosine normally starts on that y-axis. What happened is we reflected it over this dotted line, so we're going to have a negative a value, even though our amplitude is 3. Okay, and then the vertical shift is one that I'm going to come up with after I start working with the graph, just because of how odd this thing normally looks. So I'm going to have -3 cosine, and then I got to figure out what b should be. So if 2 pi over b is going to equal 6, in order to figure out what b equals, I'm going to have pi over 3. Okay, I do that by multiplying both sides by b, dividing both sides by 6, and then simplifying. So if I've got b over 3, or excuse me, if b is pi over 3, I've got this. And you could write this a few different ways. I often like to put everything in the numerator that I can, just so that I don't accidentally put an x in the bottom when I'm trying to graph in a calculator or something. But this is not my final answer because I still haven't figured out my vertical shift. So to figure that out, I'm going to plug in some numbers and see where I'm at. So if I plug in 0, cosine of 0 is going to be 1, times -3 would be -3. I'm supposed to be at -1, so I'm thinking this is going to be a +2. All right, but let's double check some more numbers. So I plug in 6, that gives me cosine of 2 pi, which is still 1. Get the exact same thing. Okay. If I plug in 3, that gives me cosine of pi, which is -1, times -3 is going to be +4, plus 2 gives me, did I just say that 1 times 3 is 4? Wow. -1 times -3 is +3, plus 2 gives me 5. All right. So those values are good. Now, I want to check these ones, but I can't really see exactly where they're at. So I have to check just those 3 and kind of assume that I'm good to go there. But that one, in my opinion, is probably the trickiest of all of the problems today. Just because, A, you have to identify that it's going to be a cosine. Okay, you could try to model this with sine, but that's going to be a little bit harder to do. You might have a bigger phase shift. The phase shift is an odd one. I mean, we rarely have a phase shift of pi over 3 so far, at least. Okay, figuring out what that b value is. We're lucky that we didn't shift it left or right at all. That could have made it even more challenging. So there's a lot that was going on in this problem. Number 6 is also tricky because it is not going to be sine or cosine or tangent. Okay, we can tell that this is either a secant or a cosecant. So before I worry about any of this, I'm going to actually try to figure out what that reciprocal function is going to be. Now, obviously, when I'm drawing this reciprocal function in, it's not going to be perfect, okay? I'm trying to just estimate where things are going to be, so I can get a better representation maybe of what this thing looks like. Okay, so in here, this is how I'm going to find, this is not supposed to be shift, this is supposed to be vertical stretch. This is where I'm going to figure out my amplitude and period and such. So of this green piece, I have a highest of 3 and a lowest of -1. So that means I'm going to have a vertical stretch, or an A value, of 2. Okay, if there's like the middle of that function. The period, okay, you can go through this a couple different ways. Basically, you pick where the red and the green things match up, and you can go from there. Okay, I'm going to go from this one to this one, from pi over 2 to 5 pi over 2. That's 4 pi over 2, which is 2 pi. My phase shift, I'm going to the right pi over 2. So I'm going to have a phase shift of pi over 2. Okay, because right now I'm thinking this is cosine. I went from the top to the top, in this case bottom to bottom. So I feel like that's probably going to be cosine instead of if I had gone a full sine wave instead. And then my vertical shift, okay, normally we would have been with a vertical stretch of 2, we would have been at +2 and -2, but we went up 1 to get to +3 and -1. So in the green, I'm going to figure out what that thing is first, and I know that that is not my correct answer. So I could have y, you can maybe label it y1 or some other denotion. I have an A value of 2, but if I think of my starting point on this green thing right here being below 0, when cosine normally starts above 0, that tells me I should probably have a negative. So I'm going -2 cosine of x minus pi over 2. Okay, I just had x because my period is 2 pi, so my b value is 1, minus my phase shift, which is pi over 2, over b, which is 1, plus 1. So I think this is my green function. So if I plug in some green values, we should see what we got. So if I plug in pi over 2, that's cosine of 0, which is 1. -2 plus 1 is -1. If I plug in 5 pi over 2, that gives me cosine of 2 pi, so I'll do the same thing. If I plug in 3 pi over 2, that becomes cosine of pi, which is -1 times -2 is +2 plus 1 is 3. So the green one is good to go. So now I actually have my real answer. And this is where we might make a mistake. The -2 needs to stay in front. I'm just changing cosine to its reciprocal, which is secant, and the rest stays the same. The reason what I'm saying, like this needs to change, or -2 needs to stay exactly where it is when I change from cosine to secant, is it's going to be tempting to say, well, cosine of x equals 1 over secant of x, so it's tempting to want to throw the 2 in front of that secant, which is wrong. You're going to have go from doubling something to a half of it, so you're off by a factor of 4 there. So make sure that -2 stays out front where it's supposed to, and then just change cosine to secant, and that should be your correct answer. But let's double check. Okay, if I plug those same numbers I just plugged in, I should get that same value. So if I plug in pi over 2, secant of 0, well, that's just going to be 1 times -2, and so on. That works. A value we should check is 0. Because if I plug in 0, this is supposed to be on an asymptote. Same with on pi and 2 pi and 3 pi. I should get an undefined answer. So if I plug in 0, I've got secant of -pi over 2. Well, if secant of -pi over 2 is the same thing as 1 over cosine of -pi over 2. And cosine of -pi over 2 is 0, so that's going to give us an undefined answer since we'll have a 0 in the denominator. Okay, that same thing goes with every multiple of pi after that. There'll be one of the pi over 2 or 3 pi over 2 results in our unit circle. All right, so there is your assignment. Hope everybody has a great day.